What are recursive functions in Python, and how do they work? Imagine you have a puzzle that keeps breaking down into smaller, similar puzzles until it becomes simple enough to solve directly. That's kind of how recursive functions work in Python. When you define a function to solve a problem, sometimes it can call itself to handle smaller parts of that problem. This approach is called recursion. Every recursive function needs a stopping point, which is called the base case. Without it, the function would keep calling itself forever, causing an error. The base case is like the finish line that tells the function, "You're done now." For example, when calculating factorials, the base case is when the number reaches 0. At that point, the function just returns 1 and stops calling itself. The other part of recursion is the recursive case. This is where the function calls itself with a smaller or simpler input. It's like breaking a big task into smaller tasks. For example, in a factorial function, you multiply the current number by the factorial of 1 less than that number. Each call gets closer to the base case. When you run a recursive function, it keeps calling itself with smaller inputs until it hits the base case. Then, it starts returning values back up the chain of calls. These returned values are combined to give the final answer. Think of it like stacking blocks and then unstacking them to see the final result. Let's look at an example. The factorial of a number is the product of all positive integers up to that number. In Python, you can write a recursive function for factorial like this. Def factorial n. If n is equal to 0, hash base case. Return 1. Else. Return in factorial n1. When you call factorial with a number like 4, it multiplies 4 by the factorial of 3. Then, it multiplies 3 by the factorial of 2, and so on, until it reaches 0. At 0, it returns 1, and all the previous calls multiply their numbers back up. Recursive functions are useful for solving many types of problems. They work well with mathematical sequences like Fibonacci numbers or factorials. They're also great for navigating data structures like trees or graphs. Sorting algorithms like quicksort and mergesort often use recursion to break down problems into smaller pieces. But remember, always include a clear base case to stop the recursion. If not, your program could run forever and crash. Python also limits how deep recursion can go, so very deep recursive calls might cause errors. Understanding recursion helps you write cleaner, more efficient code for problems that naturally fit into smaller, similar subproblems. It's a powerful tool in the Python programming core, especially when working with functions and modules.